Calcium is the third element in group 2 on the periodic table. It's really very common. We find it all over the world in all sorts of minerals. So, for example, you can have bones. This is a pelvis of a sheep. I found it when I was walking one day. You can see the legs go in there and there.
Okay, so here we have some calcium turnings, okay? So, and we're storing them in our glove box. So this glove box here is a contraption full of nitrogen. Okay, it's dry nitrogen, so that we can keep our calcium away from oxygen and away from moisture as well. Because obviously what we don't want is when we get our nice, very reactive calcium surface, we don't want it to tarnish from oxides, you know, too quickly before we can react it with things. So what we have here inside the bottle are turnings of calcium. Calcium's quite hard compared to sort of the heavier group 2 elements, so strontium and barium, so it's harder to kind of file.
Bones are made from calcium phosphate, mixed with some organic material as well, and they're very strong because of the structure within the bones. There are all sorts of shells of mollusks and the like where they use calcium carbonate from the sea water, getting the calcium out, reacting with carbon dioxide and making their shells. And because shells are made out of calcium carbonate, which dissolves in acid, people are quite worried about the effects of global warming. Not the heating up, but when the CO2 dissolves into the sea, it makes it more acid. So in principle, shells could start dissolving, and some mollusks may not be able to survive because they just can't make their shells.
If I just pour them out so you can see.
Calcium looks metallic, the calcium metal itself, because of the way the electrons behave in the solid. In fact, it's because it's a very good electrical conductor. But the compounds are all white because calcium has no free electrons that can go from one energy level to another in the way that you can say in copper. So copper sulfate is a beautiful blue colour, calcium sulfate is white, and it's actually colourless. So if you see a big crystal of calcium sulfate, it just looks like glass. But the white is caused by very small crystals which scatter the light just in the same way that any sort of white powder will scatter light. Flour, for example, or talcum powder, anything like that.
And calcium compounds themselves are actually mostly white, actually. But calcium metal itself, as you can see, we've got tarnished parts, but also there are some shiny bits, okay, where it's kind of untarnished. So you're actually seeing the metal, the luster of the metal there as well.
Calcium carbonate dissolves in water saturated with CO2 to make calcium bicarbonate, which is more soluble. And so you can get water, so-called hard water, that has quite high levels of calcium. And when this percolates through the ground and comes to a cave, it can then crystallize out, and you can get hanging down pillars of calcium carbonate, which are called stalactites, and you can have pillars growing from the floor called stalagmites. This is a stalagmite from Turkey. One of my friends called Hugh was really naughty. He knew I was interested in minerals, and he broke this off from a cave in Turkey about 45 years ago and brought it and gave it to me. So I was really pleased. And you can see the outside looks quite blobby, and inside you can see there are nice crystals of calcium carbonate because it has grown very, very slowly, and so it can crystallize. And sometimes these stalagmites and stalactites can grow really big. And more recently, in the last few years, people have found huge crystals of calcium sulfate under the ground. Some of you may have seen pictures of caves in Mexico where they're crystals, they're big enough that you can actually walk along them. So there's no danger that calcium will ever run out. It's the basis of cements and concrete, or one of the bases, because then you need other elements like iron and silica to make the concrete itself. But calcium is one of the principal components.
We're going to take calcium chloride, put it in a flame and do a flame test and see if we can see the colour of the calcium in the flame. So as I said before about calcium compounds are often white, and here's a white calcium compound. So I'm going to put it in the flame and see if we get any colour. Oh, hello! That's quite red, doesn't it? Okay, so brick red is the classic calcium colour. Kind of a bit orangey to me, which might be a bit of sodium in there or something like that. That was our calcium flame test.
The reason that you don't find lumps of calcium metal lying around the way that you do with copper or gold is that metallic calcium is very reactive, reacts with water very quickly. Magnesium doesn't react because it has a layer of oxide on the surface. So surprisingly, magnesium is not nearly as reactive as calcium. You can use magnesium or its alloys for the wheels on your car. Go round really fast because they're light. You couldn't have calcium wheels in your car. Well, you could, but the first time it rained, your whole car would go up in flames.
So again, what we've got is our calcium chloride, hydrated calcium chloride. We've got a bunch of it on this spatula. I'll put it in the flame, and so you can see that it's burning with a brick red flame, which is characteristic of calcium. It's kind of a little bit orangey to me as well, actually. Might be a bit of sodium or something in there. Got any more in there? A little bit.
Many people see calcium as a very English element, unlike strontium, which was discovered in Scotland, because of the White Cliffs of Dover, the gateway for many people when they first come to England. They're made of calcium carbonate, and so this white colour of chalk is very characteristic. And all over the southern part of England you find large amounts of chalk, which in the north of England they tend to be limestone, which is also calcium carbonate, but a slightly different variety of calcium carbonate. So it's a yellow or honey colour because of the impurities of iron or some other element that's in it. Well, you need calcium for all sorts of processes in the body, and of course to build up your bones. Particularly is, say in the case of pregnant women, they need to have calcium for the bones of the developing baby. But as people get older, the calcium can come out of their bones, make them very fragile. This is why elderly people sometimes break their hips and break their bones so easily. So drinking milk and other sources of eating other sources of calcium are good because it helps you replenish your bones and keep a reasonable level of calcium